Welcome to DataDo Library. In today's video, we're going to talk about functions. We will review what functions are all about, and we're going to go through this practice test, hopefully giving you a better understanding of what functions are all about. So let's begin. This question asks about the ratio of the change in y with respect to x. In other words, ratio is another word for division. So if we're going to divide y divided by x, and even more, we're going to divide the change of those two variables, we're obviously talking about slope, which the slope formula is m is equal to y2 minus y1 over x2 minus x1. So this fill in the blank is slope. Question number 2. Estimate the slope of the line. So another word for slope is rise over run. Rise over run, we're going to look for 2 points that intersect somewhere nicely. And then we're going to calculate the rise and then divide it by the run. So I'm going to pick 2 points. First one is going to be 0, 0. And then another one that seems to lie right on perfectly on a number is this 2, 3. So slope is nothing more than rise over run. So let's count how many spaces it goes up. 1, 2, 3. So the rise is 3, and the run goes over 2 units, which makes it 2. Therefore, the slope is equal to rise, which is 3, divided by 2, which is the run. You can also check it by going yet another point and just make sure that it ends up on the line. So from this point, I'm going to go 1, 2, 3 up, over 2, and notice it ends up on the line again. Therefore, that has to be the slope. In the next example, you're asked to find the slope of a line that passes through the pair of the points. So you have 2 points. You have 10, 0, you have 0, negative 2. What you want to do first is name those 2 points, x1, y1, and x2, y2. Now it doesn't matter which one you make x1 and y1, which one you make x2, y2. Either way is going to give you the correct answer. The slope, as we mentioned before, was y2 minus y1 over x2 minus x1. So our y2 value, notice is here, it's negative 2. Minus comes from the formula. Y1 value, which is 0, divided by x2, which is 0, minus x1, which is 10. Now, negative 2 minus 0 is obviously negative 2. 0 minus 10 is negative 10. 2 negatives divided by each other make a positive. So this will be 2 tenths, and now we can clearly reduce by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. Therefore, the slope in between those 2 points is positive 1/5. In this example, you're asked to determine whether the lines are parallel, perpendicular, or neither. So let's just review really quick what happens to the slopes of lines in order to have parallel, perpendicular, or neither. So parallel lines are two lines that have exactly the same slope. They have to be exactly the same sign, same value. Perpendicular lines exist when their slopes are exact or reciprocal and opposites. They're opposite reciprocal. So a slope that's opposite reciprocal, for example, let's say you have a slope of 1/2, 1 over 2. And opposite reciprocal slope would be negative, and then you flip it, which makes it 2 over 1. So what you're looking for is signs that are different, and it's also flipped, so it's reciprocal. Neither obviously means that neither one of them apply. So here we have the slope of 1 over 9. Remember, slope is the number that stands in front of x. We have 1/9. Then we have 9 as the other slope. Now they are reciprocals of each other. So 1/9 and 9 are reciprocals of each other. They're flips of each other. Unfortunately, they are not opposites.
Right?
So in order to have perpendicular lines, we need opposite and reciprocal.
They're
not opposite of each other. Therefore, they are neither, because they're obviously not the same, and they're not opposite reciprocal. Therefore, they have to be neither. Next example.
It's the same
question. Parallel, perpendicular, or neither.
So notice
the two slopes. Slope 1
is
negative 4/5. Again, the number that stands in front of x.
Slope
2
is
5/4.
So now let's
take a look at them. They're obviously not the same.
Therefore,
they are not parallel.
Are they perpendicular?
So
we look at their signs.
Are they opposite?
Yes, they are.
So that's the first step.
They're opposite.
Reciprocal means they're flips of each other. So this one's 4/5. Flip of that will be 5/4, which indeed it checks out. Therefore, perpendicular
will be the answer
to this question.
The next question. You have to find the value
of each of these functions.
So in
here you have a function h of t
in terms of
t.
We have
t
show up
here and t show up here.
Part A asks
you to plug in a 4 in where the t is.
So h of 4 would be nothing more than plugging the 4 in everywhere
you see a variable.
In this case,
our variable is t, but very common you'll see x as your variable.
Here also we have
to be careful with the negatives.
Notice that 2,
the square,
only goes to the
t, not to the negative.
So negative comes
along for a ride.
T
becomes 4
squared
plus
4 again
plus 1.
So again, that
negative comes along for a ride.
4 squared is
16 plus 4 plus 1.
So negative
16 plus 4 plus 1 would give me negative 11.
Okay? And what that means
is that for this function, when x value is 4, the y value is negative 11. In other words, there is a parabola,
and this is a
parabola because of the t squared.
In this
parabola, there exists point 4, negative 11
on the function
itself.
Okay, so
negative 11 will be our answer here.
All right,
for part B,
we're going to do the same thing.
So you're going to plug in negative 1, which makes it a little trickier with the negative signs.
We just have to be careful.
h of negative 1.
We have negative
that comes from the formula again.
T
becomes negative 1.
That's squared.
Plus
negative 1
again instead of t.
And then plus 1. Which means
negative 1 squared is positive 1. So this negative comes down from the formula. Negative 1 squared is positive 1.
Plus and minus
together make a negative
1. And
then plus 1.
So
you can just
either add these together,
or you can just cancel these two out,
and you have negative
1 as
what's left over.
So again,
on this parabola,
there's a point
negative 1 comma
negative 1
that folds right
onto this function.
The last one,
I'm going to erase here and just
get a little more room. So for the last one, the idea is exactly
the same, just a little more challenging.
So h
of x plus 1
simply means instead
of writing a number in places of t, I'm going to write x plus 1 instead of t.
So again, the
negative comes down
from the formula.
Instead of t, I'm going to write x plus 1 squared plus
t
again is x plus 1. I'm going to put that in parentheses just in case if this was negative. You have to remember to distribute through. So just keep that in mind.
And then plus
1 comes down from the formula again.
So now
you would just simplify
and just keep that negative
there.
We're not going to touch that.
But x plus 1 squared
very common mistake.
Very common mistake
is that
people will write x squared plus 1 squared, which is x squared plus 1.
And that is not
the complete answer.
X plus 1
squared
means the same
thing as x plus 1 times
itself
or x plus 1.
So we would have to
FOIL here.
First, outer,
inner, last. We multiply those terms.
And we have x squared
plus x plus x again plus 1.
We're going to combine
the like terms.
X squared plus
2x plus 1 would replaces this piece right here.
So x squared.
We'll
put that in
parentheses just to remember to distribute the negative.
X squared plus
2x plus 1
goes there.
We're going to get rid of this parenthesis here because it's just plus, so it doesn't change anything.
And then plus 1
again.
So I'm going to erase here. And what do we have? Once we simplify, we have to distribute the negative, right? So the first thing we do here is we distribute the negative. We have negative x squared.
Negative
2x. Negative 1. Plus x. Plus 1. Now I can go ahead and combine like terms.
So notice x squared doesn't have anything to combine with.
I'm just going to leave it
as x squared.
So we have
negative x squared.
Negative 2x,
positive x
combine
to make negative x.
Then negative 1
plus 1 that's 0 plus another 1 that's plus 1.
And that is my
final answer. Next question. Very similar to the last one, you just have to plug in what's inside of the parentheses in for x. And in this case, we only have 1x. So we have f of 9 just means absolute value of 9 plus 4. Absolute value of 9, absolute value of anything is just going to produce a positive result. So we have 9 plus 4, which is 13, and 13 goes here. So on that absolute value, we have a 0.9, 13. If we plug in negative 9 plus 4, negative absolute value of negative number turns into a positive. So again, we have 9 plus 4, which is again 13. It would be 13. And then lastly, we have absolute value of x squared plus 4. And I'm sure, as you know, if you take any negative number and you square it, it's always going to be positive, right? So any number squared is always going to be positive. So there really is no need for those absolute values here, because any number squared is going to give you a positive result anyway. So really the answer is just x squared plus 4. X squared plus 4. Next question. Find the domain of the function 8 over x squared minus 2x. So whenever you have a rational function like this, what you want to do is set the denominator equal to 0. Because whenever whatever value you get, if you plug it into the denominator, you're going to have 0 in the denominator, and that is obviously not okay. So we're going to set the denominator equal to 0 and solve for x. So in here, notice we have x squared minus 2x. X is common to both, so I can factor that out. I have x minus 2 left over is equal to 0. And you can double check that by distributing the x through. X times x is x squared. X times negative 2 is negative 2x. And now, pretend this is another parenthesis here. I'm going to set each one of these pieces, or these factors, as equal to 0. So the first one is x equals 0, and the other one is x minus 2 equals 0, so if I add 2, x is equal to 2. So those are the two values that x cannot equal. X cannot be 0 and it cannot be 2. Because if it is, if I plug it into here, I'm going to have a 0 in the denominator, and that is not part of my domain. So, and just to prove it to you, 0 squared minus 2 times 0 is obviously 0, so 8 over 0 doesn't exist. If you plug in 2, you have 2 squared, which is 4, minus 2 times 2, which is 4 again. Therefore, 4 minus 4 is 0, and the denominator cannot equal 0. So all real numbers except for 0 and -2, that is not correct. All real numbers except for 0, that's partially correct. All real numbers except for -2, that is not correct. All real numbers except for 0 and 2, yes. And all real numbers except for x equals 2, that is also not partially correct. So this is our answer.
In the next
question, we have graph provided to us. He asked for domain and range. So remember, domain is what x values this function could be.
It looks like
this function keeps going down until infinity.
Okay?
Down and to the right into infinity.
So it
doesn't have an endpoint.
So notice
the first number that the domain could be, the x value,
is here.
Right? This is my first x value.
And that
point
here is
-1,
or the x
value of that point is -1,
and the y
value is 4, so -1, 4.
But
right now we're only worried about the x value.
The first
x value that this could be is -1, and if you noticed, that dot was circled in, right? It was filled in.
If
it's filled in,
it
it means that we have to have a bracket
like this, a
square bracket
from
-1. And now, what is the largest x value this could be?
Well, it seems
like it's going on until infinity.
Therefore,
infinity would be the domain. For the range, we're going to look at the y values. What is the smallest y value this function could be, and what is the highest y value this could be? So the lowest y value, notice this function keeps going down until -infinity. It keeps going down. So the lowest y value this could be is -infinity, comma, and what is the highest y value could be? Well, it stops right here. So the y value at that point is +7, and that part is obviously included. Now, the next part of this question asks about what is f of -1. So now this is where the understanding of what it is that we're doing comes in. F of -1 is asking what is the value of this function at x equals -1. So here's x equals -1, which is here. So if I go up from here, where is this function at -1? Obviously, it's this point right here. So what is the value? What is the y coordinate of that point? And in this case, it's 4. What about 0? X value of 0 is here, and notice the function at 0 is here. Therefore, the y value at that point is 3. At 2, I'm going to go all the way up to where it meets the function, which notice the y value is 7. And then at 3, which is here, the y value is 0. Now we're going to get into some of the graphing questions. The first one is just to graph in a line. So remember, whenever you graph in a line, you always try to identify what it is that you have first. The number that stands in front of x is always the slope. And slope is, regardless of whether it's in the front or as a second number here, is the number again that stands in front of x, and it's also the rise over run. Okay, so a lot of times I suggest that you write that -7 as -7 over 1. That just gives you the rise and the run being -7 over 1. So 3 is my y-intercept. That's the number that stands by itself. So when I go to graph this, I'm going to start with my y-intercept, which is 1, 2, 3 up. I'm going to put a dot there. Then I'm going to look at the slope. Slope tells me that I'm going to go down 7, and then to the right 1. Okay? The negative determines if you're going to go up and down, and then the bottom number, you're always going to go to the right. So 1, 2, 3, 4, 5, 6, 7. I'm counting from the dot. That's very important. Very common mistake is that people don't count from the dot. So from the dot, I'm going down 7, and then one to the right. I'm going to put another dot. I'm going to connect these two with a line. In order to have a line, all you need is 2 points. That's all you need to have a line. And there you go. That's this question. Next one is about vertical and horizontal shifts, and there is a video about that. There's 2 videos about that, which I'll put in the link in the description down below there. For you to kind of take a look at. One of the videos was using Desmos, which again I cannot recommend enough. Desmos is a great tool, great visual calculator that will allow you to do all this stuff. So in this question, what does the C on the outside of the function do? Well, as we talked about this before, C on the outside is a vertical shift of either up and down, and since it's positive, it's going to be a vertical shift of the function f, C units up. On the outside with a negative, that's going to move it down. Therefore, it's this one, vertical shift of f, C units down. C is just a constant. Here we have a C on the inside, and if it's positive, it's going to move opposite direction of what you think. So positive moves to the left, and negative moves to the right. So it's a horizontal shift. Since it's positive, it's to the left. In this case, it's a negative, therefore it goes opposite of what you would think, therefore it would go to the right. The next question, you have a function g, which is related to a parent function. What is the parent function here? Well, if you didn't have any transformations here, this will just be x cubed. That's my parent function. So we have 2 transformations happening here. We have a positive 2 on the inside, which would move it again opposite of what you would think. Well, you would think it would go to the right, but it doesn't. It goes to the left. So it goes left 2 units, which is a horizontal shift, which is this one. And then the negative on the outside flips it upside down over the x-axis. So it's a reflection over the x-axis. All right, there is no horizontal shrink or vertical shrink. There is no, it doesn't move down. The moving downwards would mean that you would have a number on the outside. So to sketch this graph really quick, first you need to know what the parent function of x cubed looks like. And it looks like this. This is just what a parent function of x cubed looks like. So I'm going to move it to the left too. So I'm going to concentrate on this vertex here, or this middle here, and then go 2 units to the left. And I'm going to reflect it over the x-axis, which would make it look like this. Okay? Like imagine this part being reflected this way, and then this part being reflected that way, around the x-axis. And that would give me this new graph here. So there you go, that's my answer. And the next question, it's the same type of question. What is the parent of this function? Well, here we have an absolute value of x. We have down 2 on the outside, that's a vertical shift, 2 units downwards. And then we have 4 on the inside, and the 4 on the inside again is going to move it opposite of what you would think, so it's going to move it to the left 2. And it's a horizontal shift, 4 units to the left. And to graph this, I'm going to have, again, you need to know what is a vertical, what is the function absolute value, what does that look like? An absolute value, as the name suggests, it's an absolute value, or V, okay, absolute value. So I'm going to move that V, I'm going to move it down 2, and I'm going to move it to the left 4 units. So now this point right here, that's 0, 0, has moved down to -4, -2, and I'm going to just sketch a V just like that. Okay? Next question. It says write an equation of a function's graph as described below. So our parent function is x cubed, as we saw 2 examples ago. It is shifted 8 units to the left. And remember, shift of to the left or to the right occurs inside of the function. So in this case, since we're going to the left, it's going to be opposite of what you would think. Therefore, it's going to be plus 8, and that's cubed. And then 9 units down, which means on the outside, it's going to be minus 9. And then it's reflected in the y-axis. And reflection on the y-axis means that there's a negative inside here. Okay, the reflection over the y-axis is on the inside. The reflection over the x-axis is on the outside, then negative. So that's what we have here. The last two questions deal with composition of functions. In the first question, or in part A, you were asked to find f of g of x, which is just another way to write fog. So what we're going to do is take g of x and we're going to replace the domain of f of x with g of x. We're going to plug it into f of x. So I'm going to take this g of x and plug it into f of x. So as you can see here, we have 4, and then instead of x, I'm going to write my g of x, which is my function g of x, which is x to the 4th. Okay. In part 2, we have g of f of x, which is the same thing, just going in the other direction. So I'm going to replace my domain of g of x with f of x. I'm going to plug in f of x into g. So now instead of writing this x, I'm going to write 4x, and then I'm going to take that to the 4th power, which ends up being 4 to the 4th power, which is 256, x to the 4th power. And then the last one, we're going to take g of x, which means take g of x and plug it into itself. So instead of this g of x, I'm going to write x to the 4th, which now this question just becomes g of x to the 4th is equal to, now I'm going to take x to the 4th and plug it into g again, which was x to the 4th. So x to the 4th replaces x, and then I still have to the 4th power. So whenever you take a power to another power, that you multiply, which is x to the 16th. In this last question, we're going to find f of g of x. F of g of x, again, we're going to plug in g of x into f. So I'm going to take this function g of x, I'm going to plug it in where I see an x in here. So I have cube root of x cubed plus 9, and then I have minus 9 from the other, from f of x though. So to simplify this, 9 minus 9 is 0, and I have cube root of x cubed, which just so happens to reduce to x. The second function, g of f of x, it's the same thing, just go in the other direction. So I'm going to erase here. So we're going in the other direction. We're going to take f of x and plug it into g. So I'm going to take this function, I'm going to plug it into g, which is every x I see in g. So instead of x, I'm going to write cube root of x minus 9. Then I have this cube, which means I'm going to cube this and then add 9 once I simplify this. So cube root and cubed power, they cancel each other out, leaving me with x minus 9 plus 9, which is just x. And that's how you prove two functions are inverses, by the way. And the last one is g of x, which is equal to taking g of x and plugging it into itself. So I'm going to take this function and plug it in for x cubed. So instead of writing x, I'm going to write x cubed plus 9 cubed and then plus 9. And now if you wanted to simplify this a little further, you wouldn't cube this and you would not cube this. You would have to multiply it by itself 3 times. So I'll leave that up for you to do. And that is all I have for you today. Thank you very much for joining me, and I hope to see you next time. Take care.